This tutorial will be an in-depth explanation of drift tuning in Gran Turismo 7. By the end of this video, you will have a better understanding of the importance of tuning in GT7, and be able to tune your very own car for drifting. Before we begin tuning, I want to discuss the layout of the tuning sheet. This is where you will master your craft. If you look to the left of the tuning sheet, you will see your vehicle information and performance statistics. Anytime you make a change, pressing triangle will measure the new performance and allow you to compare the before and after. If you are not satisfied with your results, pressing L1 will revert to the previous tuning sheet and undo all changes. If you look at the center of the tuning sheet, you will see your tire information. Be sure you have purchased comfort hard tires, as these are necessary to begin drifting. Also, be sure you have purchased all necessary parts to unlock the custom tuning options. Beyond that, there are a few things on the tuning sheet that I will briefly discuss, as they are not essential for tuning. Aerodynamics are optional. When it comes to drifting, downforce can help slightly, but it is mostly used for style points. ECU tuning can be useful for lowering the power of your vehicle. A ballast can be used to adjust the weight distribution of your car. A 50-50 weight distribution is recommended for drifting. Although not necessary, you may choose to purchase a sequential gearbox, or fully customizable racing transmission. For drifting, I recommend using a close ratio setup to keep the engine within the power band, but it is ultimately personal preference. You can elect for a more open ratio setup in order to limit the number of shifts during your run. Nitro is also optional. The output simply dictates how much nitrous will be available for use. Turbochargers, or superchargers, can provide a much needed power increase. Anti-lag can be used to remove boost lag from turbocharged vehicles. This is only available for cars with factory-tuned turbochargers. Anti-lag cannot be applied to naturally aspirated vehicles using an aftermarket turbocharger. For all other available options, I recommend using the racing spec for each. Now let's get started. We'll begin with the LSD. The limited slip differential, or LSD, is a type of differential that allows its two output shafts to rotate at different speeds, but limits the maximum difference between the two shafts. This allows the LSD to control the amount of slip between both wheels. For example, when traveling in a straight line, and one wheel starts to slip and spin faster than the wheel with traction, torque is reduced to the slipping wheel and provided to the slower wheel, which has more traction. In the case of the vehicle turning, and neither wheel is slipping, the inside wheel will be turning slower than the outside wheel. Because of this, the inside wheel receives more torque than the outside wheel, and can result in understeer. This can be adjusted by tuning your LSD. A properly tuned LSD is considered essential for drifting. All other modifications come secondary to the LSD. The minimum setting of 5 will apply very little torque resistance, operating as an open differential. The maximum setting of 60 will apply the maximum torque resistance, operating as a locked differential. It is recommended to use a setting between 40 and 60 for drifting. The preferred setup by many drifters is to use a two-way LSD. This is due to its consistent and aggressive lockup behavior under both acceleration and deceleration. Some drifters also use a locked differential, as this makes the car extremely predictable. However, this can also make the car a lot less forgiving. So, if you want to set it and forget it, you can purchase a two-way LSD from the tuning shop. Or you can buy a fully customizable LSD, and set it to 60-60-60, for a fully locked differential. While a two-way or locked differential are great choices for most drifters, understanding how to tune your LSD for specific track patterns is what will give you the competitive edge. With a properly tuned LSD, it can be adjusted to unlock when you release the throttle, offering faster and smoother transitions. For those looking to advance their tuning, we will now dive deeper into understanding the LSD. This tuning is make or break with drifting, so getting it right is crucial. If you have tried tuning your LSD and haven't had the best results, then this explanation should help you understand why you are having wheel spin, understeer, lack of speed, and snap overcorrection problems. A tightly tuned LSD, or a LSD with a high amount of torque resistance, will make the car a lot more stable, adds a lot more throttle control, and will make the car hold its speed better while drifting. However, locking it fully will mean that the car will not turn without wheel spin, and loses some maneuverability. Having a loose LSD will create the opposite effects and make the car a lot more maneuverable and a lot easier to wheel spin. This will also make it a lot harder to get oversteer. While going too loose will cause what we call peg legging, or one-wheel burnouts and, consequently, understeer. When it comes to LSDs, there are a few common setups. The one-way setup. 565. The two-way setup. 560/60. And there are different variations in between. Like the 1.25-way setup, 560/15. The 1.5-way setup, 560/30. And the 1.75-way setup, 560/45. Using a one-way setup will allow the LSD to lock under acceleration, and open during deceleration. Using a 1.5-way setup will allow the LSD to have some slip under acceleration as well as some slip under deceleration. But neither is fully open, as in a one-way setup. The slipping offers slight torque transfer without fully locking the differential. This can provide a more forgiving balance for beginners during no throttle conditions. Using the two-way setup will offer the same limiting torque under both acceleration and deceleration, and allow for a balanced and moderate amount of slip under load. I recommend starting with one of these setups, and begin tweaking as needed. Now, back to tuning. Initial torque. This setting determines the amount of torque resistance when under load. In other words, it determines how much lock will be applied under initial acceleration or deceleration. A higher setting will result in the LSD applying more lock under acceleration or deceleration, making the car more responsive. Consequently, it will also be tighter when not under load, causing understeer. A lower setting will result in the LSD allowing more slip under load. You should aim to keep this between 10 and 30. But this will vary depending on the vehicle. Set this too high, and you sacrifice maneuverability, but it will also make drifting a little easier. Another thing to keep in mind is that initial torque is a factor when considering the total application strength of the LSD. For example, if you set the initial torque to 5, then there will be no responsiveness, because there is very little torque resistance being applied, essentially operating as an open differential. Conversely, if you set this to 60, your LSD will be locked all the time and will not need to respond to acceleration or deceleration. If you decide to use either of these setups, then the acceleration and deceleration settings become irrelevant. Note, the initial torque setting affects both the acceleration and deceleration. Increasing this will make your car looser during wheel spin, but tighter the rest of the time, causing understeer. This will also decrease maneuverability. This means you will be unable to corner without wheel spin. Now that we understand how the initial torque setting affects the LSD, let's move on. Acceleration sensitivity. This setting determines the level of torque resistance when accelerating through a turn. The higher this number, the more lock will be applied, causing the torque to be evenly distributed to both wheels. This will make your car more stable during wheel spin and give you more throttle control. The lower this number, the more slip will be allowed, increasing the amount of wheel spin the inside tire will have. Warning, as previously stated, locking the differential means you will not be able to turn the car under acceleration without wheel spin. This is why a fully locked differential is recommended for drifting purposes only. Note, increasing the acceleration sensitivity will give more lock, thus increasing traction. This then allows you to utilize the traction to move the car forward during a drift. If your car feels too twitchy while drifting, try increasing your acceleration sensitivity. Beware, setting this too high will result in snap overcorrections. Now, on to the next. Braking sensitivity. This setting determines the torque resistance during deceleration. The minimum setting of 5 acts as an open diff. The maximum setting of 60 acts as a locked diff. I recommend that you keep this between 10 and 20. But feel free to experiment. The more torque resistance, the more stable your car will be under deceleration. Warning, don't set this very high or you will create understeer while braking, which will make braking drifts impossible. Also, don't set this too low or you will start peg locking, one-wheel braking, or e-brake locking, which will also create understeer and make braking drifts impossible. A low value will be perfect for locking both rear wheels with e-brake application or large rear brake bias without creating understeer under braking. Note, increasing braking sensitivity will make the car more stable under braking, but too much will create understeer. Also, none at all can create understeer as well. So, now that you're a master at LSD tuning, let's move on to the second most important modification you will make for drifting. Suspension tuning. A properly tuned suspension is very important, and will make the car easier to handle in drift, as well as speed up your learning curve. Let's start with one of the biggest issues I see with most builds. When setting up a drift build, or any build for that matter, you want to avoid committing one of the deadly sins of suspension tuning, lowering your car too much. Oftentimes cars are slammed, simply because they look good in photos. However, the suspension was not designed to work at such low angles, and this results in poor performance. Ideally, you want to avoid lowering your car more than 2 inches. Anything beyond that point and you will begin to change the suspension geometry. Doing this will ensure you have plenty of will travel for your drift car. You want to avoid having the car bottom out during a drift. When adjusting the height, make sure to adjust the spring rate and damping rate as well. Typically, when lowering the car you want stiffer springs and dampers to reduce will travel. Setting the front ride height slightly lower than the rear can help induce oversteer. Just be sure not to overdo it, or it will hinder performance. Now, once you've set the proper ride height, let's move on to spring rate. On the tuning sheet, you will find the spring rate labeled as natural frequency. From this point, anytime I say spring rate, I am referring to the natural frequency, as labeled in game. Okay. When setting the spring rate, you want something with a good balance, while not being too stiff. Race car stiff is not recommended. For drifting, you want a spring rate only slightly stiffer than what comes stock for your vehicle. You also want a spring rate that is slightly stiffer in the front than the rear. This can be helpful because many cars have different motion ratios that put different leverage rates on the front springs and the back springs. When adjusting the damping, avoid making them too stiff. This will cause the car to hop and bounce around during a drift, making it hard to control, even though it may feel responsive to steering. However, too little damping, and the car will feel wobbly and unresponsive. Remember, don't be afraid to experiment in order to find what works for you and your car. You can use damper adjustments to control how the car initiates a drift, and how it feels during. Soft rear dampers will make the car grip up and have more forward bite, but can also make the car want to straighten up or become twitchy during a drift. Stiff rear dampers can make the car looser and easier to initiate drift. Soft front dampers will cause more understeer, offering less turn and response. Stiff front dampers will cause more oversteer, offering more turn and response. I recommend that you find a setting you are comfortable with, and that provides a solid foundation before you begin tuning the anti-roll bars. This is because when running into issues at the track, it is easier to make sway bar adjustments on the fly than it is to make spring rate and damper ratio adjustments. Also remember, when making adjustments, only change one parameter at a time. If you change the spring rate, damper ratio, and anti-roll bar at the same time, then it will be much harder to tell which adjustment made things worse, and which one made things better. Now, on to the anti-roll bars. Anti-roll bars work by transferring the load from one side of the vehicle to the other. The stiffer the bar, the more body roll is restricted. Tuning these properly can make a car feel much more stable during a drift. They also allow you to adjust how easily a drift can be initiated, and how much angle you can run in a drift. I recommend running anti-roll bars that are about 20 to 50% stiffer in the front than the rear. Some drifters may choose to completely remove the rear anti-roll bar to allow easier drift initiation. This can be done by setting the rear anti-roll bar to the lowest setting of 1. Properly tuned anti-roll bars can make drifting much easier because the car responds faster and becomes more predictable. So, we've set the proper ride height, we've adjusted our spring rate and damping ratio, and we have a good setup for our anti-roll bars. It's time to discuss another issue I see with drift builds. Camber angle. Much like ride height, wheel camber is often overdone for appearances. When it comes to front wheel camber, you can go with anything between 3 to 4 degrees of negative camber. This will help keep the tire flat on the ground when experiencing side load. When under load, the tire wants to flex and lift the inside of the tire off the ground. As the car rolls, it too is trying to tip the tire to where the inside tread is being lifted. Running negative camber will counteract this. By keeping a better contact patch, it allows for more front grip, and less understeer. The last thing you want is your drift car to have an understeer problem. For rear wheel camber, I recommend running it at 0. This will offer the best forward bite. If you want a little more side grip, you can run -1 degree of rear camber, but nothing more. Toe angle. For the front toe angle, I recommend running a slight amount of toe out. Anywhere between 0.12 and 0.25. This will help you to initiate better by allowing the car to turn in sharper. As for rear toe angle, you will usually want a slight toe in. Between 0.12 and 0.25. Never run too much toe in, or the car will straighten up if the throttle is lifted. This will cause loss of control and most likely end in a collision. Never attempt to change the car's understeer or oversteer balance by making toe adjustments. If you want to increase oversteer, and give the car a looser feel, increase the rear bar stiffness and/or rear spring rate and damper ratio. If you want to reduce oversteer, and make the car feel tighter, soften the rear bar, and/or spring rate, and damper ratio. Finally, the last thing we will discuss for suspension tuning will be the steering angle adapter. This modification can be used to increase the car's countersteering ability and help to prevent you from spinning out. You can also choose to purchase a hydraulic handbrake for drifting, as well as a brake balance controller. This will allow further adjustment, for easier initiations. So, by this point, we have gone over the importance of the LSD, we've discussed proper suspension basics, and we've even gone over optional modifications such as steering angle adapters, and hydraulic handbrakes. I hope that this guide was able to provide you with a solid foundation to begin your journey as a tuning expert. Please like the video if you found it helpful. Thanks for watching.